All right, so this is going to be a video on how we can approximately sketch a graph of a polynomial function once we have determined its roots. So I'm going to start off with this big, long, nasty thing, which is actually the problem that we worked on earlier, just expanded. And you can see that here, that it's in factored form. It's x minus 3 squared times x plus 2 times x minus 1 cubed. Okay? So the first thing that we need a few things to help us sketch this graph. The first thing that we need to know is the degree of the polynomial, so that will help us with the leading coefficients test, which comes next. We need to identify our roots and their multiplicity, and then finally we can use the y-intercept or really any other point to help us determine how our graph is going to look. So these graphs probably aren't going to look perfect. You can always check on Desmos to make sure that they somewhat resemble it, but at certain points there should definitely be a common thing. If you compare your graph with another person's, they should look relatively the same even if they're not perfect. Okay, so the first thing that we want to start off with is looking at the degree of our polynomial. This should be pretty straightforward. We did this last week. Our degree of our polynomial is the number or the power of the x term with the highest power. That would be x to the 6th here. They're listed in order in this case, so that makes it easy for us. So we have a degree 6 polynomial here, which is very high. And we now, based off of what we know about the leading coefficients test, which you guys discovered earlier, and probably you had been introduced to it at the end of last year. Our leading coefficients test, we want to look at our leading coefficient first, the sign of our leading coefficient. So our leading coefficient is 1, so it is positive, and then we want to look at whether the degree is even or odd. In this case, our degree is 6, which we found earlier. 6 is obviously an even number. So we have a positive, even combination for our leading coefficients test, which tells us that from the left, our graph is going to rise to infinity. So as we go closer this way, we're going to go up to infinity. And as we go towards infinity in this direction, we're also going to rise in the y value towards infinity. Okay, so that tells us where we're going to start and finish. So that's why the leading coefficient test is important. Everything in between is going to be based off of roots and multiplicity here. So I have it over here already, roots and multiplicity. So our roots are x equals 3. This has a multiplicity of 2. I have a root at x equals negative 2. That has a multiplicity of 1. And I have a root at x equals 1, and that has a multiplicity of 3. So if I look at my multiplicities here, this means that I'm not going to cross, which I'm going to write NC, not crossing. This is odd, so it is going to cross. And this 3 is also odd, so at 3 it'll also cross the x-intercept. Finally, y-intercept is just a useful point. Sometimes, in this case it might not be, but we'll see. So my y-intercept occurs whenever x equals 0. If I plug x equals 0 into this equation, all these are x's except for this last term, so my y-intercept is at 0, negative 18. Okay. So now what I want to do whenever I start sketching out a polynomial function is I want to mark where the roots are going to be. So I have a root at x equals 3. This is 3. I have a root at x equals 1. And I have a root at x equals 2, or negative 2. So you want to start off by doing that, and that'll make your life a lot easier. So you're basically going to break this down into chunks. So we're going to move from left to right and just fill in every space here. So there's really like 4 spaces. So there's here, 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 and here. And those are the parts that you have to draw. So let's try and make it easy on ourselves. So our leading coefficients test tells us we have a positive leading coefficient and an even degree, which means that we are going to rise to infinity as we move to the left here. So I know that this graph starts off at infinity, it's going to come down, and it's going to approach 2 in some way. Okay? Or negative 2 in some way. So negative 2, if I look here, I have a root at negative 2. It has a multiplicity of 1. Multiplicity of 1, which means since 1 is an odd number, it is going to cross the x-axis right here. So it's going to cross something that looks like that. Okay? It's going to go straight through it. So now, going to consider the interval between -2 and 1. I know that somewhere down here I have my point at -18, so my graph is going to cross through that at some point. If you looked at Desmos, it actually goes like this. If you're just drawing it straight through, it's whatever. It's kind of hard to do without doing everything. Okay, so it's going to come through here, and it's going to come back towards 1 eventually. So it's always, when you graph your roots, your graph is always going to come back to the root. So it's always going to touch there. So you always know that even if it goes down here, or if it goes only a little bit, it's always going to go back to the next root. At x equals 1, we have a multiplicity of 3. 3 is an odd number, which means, again, our graph is going to cross through the x-intercept here. You'll start to realize that as the multiplicity gets higher, when your graph crosses, it's going to look a little bit flatter. It's not going to go straight through, it'll be a little bit flatter. So it's going to come through, and it's going to cross. Finally, I know that at x equals 3, this is my last root, this has a multiplicity of 2. 2 is an even number, so it's not going to cross back below the x-axis. So it's going to come up maybe like this. It's going to come back down, but instead of going back through like all these other ones did, it's going to go, it's going to just touch, and it's going to start going back the same direction. This makes sense because our leading coefficients test tells us that as we go off in either direction towards infinity in the x values, our y values are also going to approach infinity, so it's just going to keep on going up like this. So this is a general sketch of our graph. If it's not perfect, and if it's not the same as someone who did it exactly like you, that's fine, but you should start off by noticing that it's going to start from infinity. It's going to cross -2 because it has an odd multiplicity. It's going to come down, it's going to cross through 1 because 1 has an odd multiplicity. And it's going to come back to 3, but not cross through because there's an even multiplicity at 3. So this is what your graph should generally look like. It should be correct in the end behavior, and it should be definitely correct in terms of what's happening at each root. Okay? So if you can list these 4 things basically, so degree, figure out the leading coefficient test, and then list your roots and their multiplicity, and maybe the y-intercept, you should be able to draw most of these graphs of all the polynomials pretty easily. So if you have any questions, obviously come talk to me. But this is how you would sketch an approximate graph of any polynomial as long as you know the roots.